Welcome to SST College of Arts and Commerce. This is SST Edupedia. Myself Jyoti Sardar. Today we are going to talk about the SDLC models of software engineering subject semester 4. Yesterday in the previous lecture we have covered the three models of the SDLC, that is waterfall, incremental and RAD. So next let us see the further models. First model in this series is the incremental SDLC model. So it constructs the model in an increment. So a very quick product is created, that is with the first version, and it has a few facilities in it, and that increment is released for the customer to evaluate. After the first iteration, the customer is going to give its input, and on basis of that the changes are suggested in the next increment, and so on the development proceeds. So inside the module you can say the piece of code is developed. So it constructs a partial implementation of the total system, then slowly adds the incremented functionalities. The incremental model prioritizes the requirements of the system and then implements them in a group. Each subsequent release of the system adds a function to the previous release until all the design functionality has been implemented. It also has verification and validation techniques. The strength of incremental model are: it develops high risk, each release is delivered as an operational product, customer can respond to each build, uses divide and conquer breakdown of task, lowers the initial delivery cost, initial product is delivered in a faster manner, customer get important functionality early, risk of changing requirement is reduced. So it is basically called as a divide and conquer strategy, which is very important in one of the concept or one of the subject, that is your data structure. So it introduces that concept where a problem can be solved by dividing that problem into sub problems. So sub problems can be solved separately and then the results can be combined. So that is a divide and conquer strategy. Conquer means here combining. So after dividing we are also supposed to have a work of combining it. So that is the conquer. These are the weaknesses of the incremental model. So it obviously requires a good planning and the design, because once I say that I have created an version which is a first version, okay, and then later on I feel that I should change the design, so that is not a good approach. So while releasing the first, we can say the iteration itself, first increment itself, one has to be sure about the design and the complete plan. Requires an early definition of complete and fully functional system to allow for the definition of increments. Well-defined module interfaces are required, which I have already mentioned that if I do not define my module, that what is my module is going to do, then later on it is going to become real difficult. Total cost of the complete system is not lower. So what is happening is we are developing the system in increment, so overall the cost is not reduced for the development. So when to use this module? That is when the early realization of benefits is going to happen, that is for the funding, for the schedule, when we are aware of the benefits. Next, most of the requirements are known but expected to evolve over the time. So if I know the requirements at the beginning, few requirements are known, I can go ahead, and later on some requirements can also be added. And next is need to get the basic functionality to the market early. So if I say that I need to develop some product very early, so with few functionalities, so I can deploy that product. Next, on projects which have lengthy development schedule. So there are projects which goes on for years and years, so for that we can use the incremental model. So on a project with the new technology, somewhere new technology has to be incorporated, incremental model is suggested. The next model that is there, that is your spiral model. So it adds the layered functionality to the development. So it adds somewhere the risk analysis it does, and then also the RAD prototyping to the waterfall. So in the earlier PPT we have seen what is RAD model. So it combines the risk analysis along with the RAD prototyping to the waterfall model, and that's how we construct a new model, that is the spiral SDLC model. Each cycle involves a same sequence of steps as the waterfall model. So somewhere determining the objective and alternatives and finding out what are the constraints that are there, is it fine? And then planning the next phases and finding out what are the requirements, creating a design, and then ultimately implementing the code. So this particular process is executed in a layered like fashion. Okay, so it also has a task of identifying and resolving the risk. So that is one more layer somewhere it is added in spiral model, which we have not seen at all in the earlier model, that is incremental, waterfall, RAD model. Let us see the strength of the spiral model. So it provides an early indication of unknown risk. Users see the system early because of the rapid prototyping tool. So same strategy of rapid development is used. Hence user can see the system early. Critical high risk functions are developed first. The design does not have to be perfect. So I have somewhere a skeleton prepared and I follow that skeleton, which may not be perfect. Users can be closely tied to all life cycle steps. Early and frequent feedback from users. Next, cumulative cost accessed frequently. The weaknesses are as follows. Time spent for evaluating risk is too large for small or low risk projects. Is it fine? So for a small project also, it is the time spent for evaluating the risk is again high. Time spent in planning, resetting objectives, doing risk analysis and prototyping may be again excessive. This model is complex. The risk assessment is done by the expertise, so that cost an additional amount. Developers must be reassigned during the non-development phase activities and may be hard to define the objective verifiable milestones. So when should this model be used? When the creation of prototype is appropriate, when the cost and risk evaluation is important. For medium to high risk projects, so for small we can say size project, it should not be suggested. Long term project commitment. Users are unsure of their needs and requirements are complex. The next model that is there, that is agile model. So it has a task of again speeding up the project by bypassing one or more phases. So bypassing simply says that we are not going to follow each and every phases. So which are the phases? The phases are nothing but planning, analysis, design, implementation, testing, maintenance. So we can bypass one of the phase and go to the next phase. Usually less formal and the reduced scope. Used for time critical applications. Used in organizations that employ disciplined methods. So following are the methods that are followed for agile. That is adaptive software development, then feature driven development, and cyber clear or crystal clear. Next, dynamic software development, then rapid application development, Scrum, extreme programming, rational unified process. So we are going to see out of that the extreme programming method. So for small to medium size team developing software, extreme programming can be used. Coding is the key activity throughout the software product. Communication among the teammates is done with the code. Life cycle and behavior of the complex project and objects is defined in the test cases, again in the code. So in extreme programming there is a concept of story to be written. Okay, so when a particular development has to be done, it is created by writing somewhere the stories. Thank you one and all.